Far better than any scientist's wildest dream, NASA's new James Webb Telescope is worth every hype it has received so far. The past few months have brought a new dawn to space exploration among members of the scientific community, and this is all thanks to the JWST Space Observatory. However, that's only the tip of the iceberg. Recently, the telescope has demonstrated its unmatched ability to investigate the atmosphere of a large exoplanet more than 1,000 light years away, which was more like a dream come true for astronomers. Combining the brute force of its 270-feet mirror, precision spectrograph, and sensitive detectors, the JWST has discovered in a single observation obscured signs of water, the indication of haze and proof of clouds' existence which were never thought to be in existence. This historical turn of events has not only shocked scientists, but has kept them wanting more. Join us in today's video as we discuss the insane and unimaginable true discovery uncovered by the JWST in its position deep in space. Before we dig deeper, this is Posh Future, where we talk about the latest discoveries in the world of science and technology. Don't forget to subscribe and click the notification bell to this channel so that you can be updated whenever new content is uploaded. James Webb Space Telescope remains a wonder before, during, and of course after its launch into the depth of the universe. However, this cannot compare to the clear, crisp and sharp image it has begun to send about the vast, dark and inaccessible regions of space. If you look at it from another angle, this has marked a unique point in how astronomers now see space. Before the birth of JWST, the most distant scientists could travel into the depth of space was about 1 million miles. Even that was considered too risky, complicated, and kind of expensive if you consider the whopping cost of $10 billion. So, for a space observatory that costs as much as this, it will make sense if it turns out perfect, right? Right. But that was not the only factor in the perfection of the JWST. Its final destination was in a region that cannot be reached on an impulse. So with that information, engineers built the JWST in such a way that could possibly tackle every problem it might encounter in its unique location deep in space. Interestingly, this telescope has been lauded by scientists for its complexity and innovation. Take, for instance, in building the Space Observatory, engineers had to think of a way to cool the telescope whenever it heats up from exposure to the UV rays of the sun, therefore enabling it to work without interference. The answer to this was a series of 5 sheets of special materials serving as a huge shield to the telescope. But what's more important, these sheets had to be precisely placed for them to work. However, each of these sheets is as massive as a standard tennis court, which poses some sort of problem during its launch. At first, these engineers thought of folding the massive sheet on the launch vehicle only to be unfolded on its journey to the depths of space, a region inconveniently inaccessible for maintenance and refueling purposes. However, as brilliant as that idea seems to be, things might really not go as planned. Thankfully, the engineers behind the innovative idea of the JWST had something better in mind. What they did was split these sheets into 18 different hexagonal mirrors and fold them up during the launch to space. Luckily for these engineers, the launch process went on quite smoothly in what can be considered a shocking miracle. With this behind us, all that's left for the National Aeronautics and Space Administration, NASA, is to position and readjust the different parts so that they can all perform together as planned. The big news is even if the alignment process that involves calibrating the location and tilting of the 18 hexagonal mirrors with a nanoscale accuracy is still in process, the JWST is already sending back incredible pictures of the vast, dark, inaccessible regions that really left scientists stunned. However, before we get into the juicy bits, you might want to know how the alignment is done. But be warned, you might need to get your minds prepared because it involves some jaw-dropping engineering tricks only geniuses could pull off. The alignment process involves 7 small motors fixed right behind each of the 18 slightly arched hexagonal mirrors of the JWST. Their purpose is to move and reshape the arc of each bit so that just one solid mirror is left standing at the end of the day. Besides, 6 of these motors are arranged in pairs equally distant and situated around each mirror bit. However, there's a 7th mirror placed right at the center and is linked to the mirror's 6 corners with struts. Okay, why struts? Struts are used so that the motor can adjust the tension of the strobes, which utilizes the arc of the mirror bits. The motors are just so sensitive that they can precisely convey the mirror about 1/10,000 diameter of a human hair. Impressive, right? But what's more impressive is that this accuracy within the fraction of a wavelength of light plays a large role in scientists obtaining high-quality pictures from the JWST. NASA's engineers applied a mathematical analysis referred to as phrase retrieval to investigate how the motion of every single bit of the mirror transformed the crisp quality of the pictures gotten. With this information, there were 2 important assignments to finish before the bit can function as a single monolithic mirror. These 2 assignments are summarized into 2 terms, namely the coarse alignment and the fine alignment. In the coarse alignment, the mirror parts were moved vertically until they aligned to form a giant mirror. In spite of this, there were still minute alignment inaccuracies that needed to be corrected to achieve the best image. And this is where the fine alignment takes place. At this junction, instead of moving the mirror parts, the small optics inside the near cam moves rather. For instance, when the space observatory is pointed at a star, the lights from the star first touch the first mirror in which the individual mirror parts are positioned so well that the light continued its path through the second and third mirrors inside the space observatory and then proceed into the near cam instrument. Meanwhile, during the fine alignment, the optics inside the near cam gets adjusted very carefully until the star is totally in focus. The coarse and fine alignment methods are repeated continuously until the most crisp image can be gotten. Speaking of clear and crisp image, let us turn our attention to the insane image released by NASA, which has shocked the entire space industry. A distant exoplanet's steamy atmosphere is released by Webb. The powerful JWST detected the atmosphere of the hot puffy gas giant orbiting a distant sun-like star. In addition, it also detected signs of clouds on ice, and this unusual yet detailed discovery remains the first of its kind to date. This only adds to the list of Webb's achievements in the study of atmosphere located thousands of light years away. Based on small reductions in the brightness of specific hues of light, indicates the existence of particular gas molecules. Mind you, the Hubble Space Telescope observed the atmosphere of various exoplanets over 2 decades ago, and once discovered water in one of such exoplanets in 2013. Yet, this cannot be compared to Webb's detailed observation, which truly depicts a significant growth in the efforts to spot potential homes aside from Earth. For now, there are over 5,000 exoplanets in the Milky Way, including JWST. It portrayed a type of gas giant that has no immediate peer in our solar system, dated roughly to be 1,150 light years away in the southern star constellation Phoenix. Take for a fact, JWST can be considered the most puffier exoplanet orbiting the Sun with a mass below that of Jupiter's and a diameter 1 or 2 times greater. Another distinguished fact which might interest you, this exoplanet is undeniably hotter with a heat wave of 1,000 degrees Fahrenheit. Without a doubt, JWST orbits around the star every 3.5 Earth days, orbiting in close proximity to it that it has oftentimes been compared with the distance of Mercury to the Sun. In fact, JWST has been considered the perfect candidate for atmospheric study, owing to its massive size, quick orbital seasons, and lack of contaminating light from near stars. A more shocking discovery was made on June 21st when the JWST was intently studied by Webb's near-infrared imagery and its latest spectrograph. The NIRSS observed this planet for 6.4 hours and watched as it moved across the star. Things started to get interesting when the final result is a light curve that shows a complete fading of starlight during its movement, and the transmission spectrum revealed the brightness variation of certain infrared light wavelengths between 0.6 and 2.8 microns. Previous undiscovered details of the atmospheres were uncovered by the spectrum. In fact, the light curve only added more proof of the properties of the planet that had already been detected by other space observatories. As a matter of fact, the clear indication of liquid, the existence of ice and clouds detected by other observations which were believed not to exist, were proven otherwise. The starlight that was decontaminated by the planet's atmosphere as it moves in front of a star is contrasted against the unfiltered starlight that is detected when the planet comes in close contact with a star to create a transmission spectrum. By observing the absorption pattern, the location and the peaks in the transmission graph, scientists were able to pinpoint as well as evaluate the plethora of crucial gases in the atmosphere of the planet. So pay attention to this. Atoms or molecules have unique patterns of wavelength, and what they absorb, similar to humans, comes with distinguishable fingerprints and DNA. With the help of the JWST infrared image and SLIC spectrograph, NIRSS WST-96b spectrum was revealed to not only possess the most precise infrared transmission of an exoplanet atmosphere to date, but also expands an astonishing variety of wavelengths, which includes obvious red light that had not been detected by any other telescope employed previously. Another impressive phenomenon worth noting is that water and other extra molecules like oxygen, carbon dioxide, and methane, which were not too obvious in the WST-96b spectrum, should be perceptible in other exoplanets and are so sensitive to this part of the spectrum, paving way for scientists to quantify the amount of water vapor in the atmosphere hindered by the abundance of elements such as carbon and oxygen with an estimated temperate atmosphere. To achieve this, scientists will be making use of the spectrum that JWST is intending to study. With the data obtained, researchers can now derive conclusions on how and when the exoplanet was formed. Advanced web design has paved a way for accuracy and exceptional clarity in the data obtained. The 270 square foot gold-plated mirror captures infrared light in such an exceptional manner. Moreover, its delicate and sensitive detectors notice the smallest variation in brightness, and its accurate spectrograph splurges light into rainbows of thousands of infrared colors. Impressively, NIRSS spectrograph can identify the differences in the brightness of colors as well as cover infrared light wavelength that we have never come across before. Besides, the infrared atmosphere of an exoplanet has been studied by other space observatories before. However, none can match the prowess of the JWST. In addition to this, scientists are going to be making use of spectrography to study the atmospheres of thousands of exoplanets scattered in space. They range from small rocky planets to massive ones that are plentiful in gas and ice. The study of exoplanets and their properties takes up almost a quarter of the JWST cycle in a single observation. However, this is truly worth it, as one single observation displays Webb's prowess in explaining exoplanet atmospheres, including the planet that might later turn out to be habitable. Let us hear your thoughts about the shocking discovery made by the JWST in the comment section below.